Module 5, Section 1, Objective 4. We're simplifying fractions to lowest terms. And again, we have done these, but not with negatives. So that's the difference between Unit 2 and Unit 4. 5. Okay, before we get into actually dividing and simplifying, I want you to remember the divisibility rules, because that's going to help. Okay, so you know a number is divisible by 2 if the ones position is even. So if it ends with a 0, 2, 4, 6, or 8, it means the number is even, right? Okay, we've gone over all of these before. Some of them are easier than others. So the 2 ends in an even number. 5 ends in a 0 or a 5. 10 ends in 0. Those are the easy ones. Okay, the harder ones are the ones they always throw at you. Okay, so in order to be divisible by 3, the sum of the digits is divisible by 3. Let me give you an example. Okay, the number 5,310. First of all, is it divisible by 2? Okay, the ones position, so that's right here, is an even number. So yes, it is divisible by 2. Okay, is it divisible by 3? The sum of the digits. So if we add all of the digits up. So 5 plus 3 is 8, plus 1 is 9, plus 0 is still 9. Okay, if the 9 is divisible by 3, which it is, right? You get 3, then the entire 5,310 is divisible by 3. Okay? And let me prove it for you here. You don't ever have to do this. That's the catch. Whoops, not 3 times, just 1 time. You can figure out if a number is divisible by these numbers without actually dividing. That's the catch. Okay? You could divide, but why would you want to if you don't have to? Bring the 0 down, and I need a 0 as a placeholder. See? It works. Okay? But they're not asking you to do that. They just want a yes or no in most cases. Whoops, I was supposed to erase instead of draw. Let's try that again. Okay. Let's skip down and do 9. The sum of the digits is divisible by 9. So I added them up. And if 9 divides by 9 equally, which it does, then that entire number is divisible by 9. Okay, and again, let me show you. So 5 times, we get an 8, and again, we need the placeholder, right? Goes in evenly. Okay, 6 is kind of related. Okay, let me erase the purple parts down here. Okay. If this whole number is divisible by both 2 and 3, then it's divisible by 6. Okay? So we knew it was divisible by 2 because it's even. We know it's divisible by 3 because the sum of the digits, or the 9, divides by 3. So because both of these work, that means 6 works. Okay? That's kind of one that you don't use very often, but it can be helpful if you're looking for bigger numbers. Okay? The ones that you're going to use a lot are 2, 3, 5, and 10. Okay? All right. Divisible by 4. The last 2 digits together are divisible by 4. Okay? So that means the 10. So 10, not 1 plus 0, but 10. Okay? So does 10 divide by 4 equally? No, it doesn't, does it? So that means it is not divisible by 4. Okay, is it divisible by 5? Yes, because it ends in a 0. if you're counting by fives, 5, 10, 15, 20, 25, 30, 35, 40, every single one of those ends in a 0 or a 5. Okay? And same thing with, it was divisible by 9, right? And with 10, if you're counting by tens, 10, 20, 30, 40, 50, etc., every one of them ends in a 0, which this one does. So it's also divisible by 10. Okay, those rules are going to help you when you're simplifying fractions because you can tell which numbers the numerator and the denominator are going to divide by. Okay, and we'll get into that here when we get to the examples. Okay, this is their process 1 and process 2. We actually had a process 3 that we used, but let me explain theirs first, and then I'll show you ours if you remember it. Okay, so we first want to write the fraction in lowest terms, divide the numerator and the denominator by the greatest common factor. Okay, so that would mean doing something like this. Okay, this is how we found greatest common factors. So we know the greatest common factor between 8 and 20 is 4. So now we're going to divide by 4, and we would get 2/5. Okay? This other way, process 2, so process 2 is write the fraction in lowest terms, write the prime factorization of the number, and the denominator, or numerator and the denominator, and then divide what is in common. Okay, so that would look like this. Okay, so I found the prime factorization of 8, which is 2 times 2 times 2, and I put that on the top. I found the prime factorization of 20, which is 5 times 2 times 2, and I put that on the bottom. I just put it in order smallest to largest, rather than largest to smallest like this was. It doesn't matter. Okay, and now it says divide what's in common, so we're dividing those, and we have 2/5 left. Okay, all right, so that's their versions. Our version that we have done in the past, process 3, okay, this is where you look at the 8 and the 20 and you figure out what goes into both of them. It doesn't have to be the greatest common factor. It can be anything. Okay, so we know that 2 goes into both 8 and 20, right? 8 divided by 2 is 4. 20 divided by 2 is 10. But now you look at the 4 and the 10, and they both divide by 2. So divide 4 by 2, you get 2. Divide 10 by 2, you get 5. And now 2 and 5 are as far as you can go. So you're done. Okay, so I tried to write it out so it makes sense. So divide the numerator and the denominator by the same number until there are no more common numbers. I hope that makes sense. Okay, I'll show you how to do it again on another problem on another page. Okay, here are the examples, process 1 and process 2 on both of those. Okay, so I'm going to zoom in and do process 3 on both of them. Okay, so you can see process 1, they divided top and bottom by 3 because that's the greatest common factor. Process 2, 9 is 3 times 3 and 12 is 2 times 2 times 3. And then they crossed out the 3's because those were common factors. Multiplied what you had left and you got 3/4. Okay, we're going to do exactly the same thing as both of those. It's just going to look different. Okay, so we know that 3 goes into both 9 and 12. 9 divided by 3 is 3. 12 divided by 3 is 4. So we get 3/4. Okay, exactly the same thing. Okay, now this one, with bigger numbers, it's actually easier, in my opinion, to do it our way because you don't have to work very hard up front. You just keep going until you can't go any longer. It may not be as short, but it works. Okay, so I'm going to rewrite it down here at the bottom. So we have 42/36. Okay, if you recognize that 6 goes into both of them, then you can be done quicker. But I'm going to assume that you didn't know that. Okay, so we're going to go back to this divisibility rule chart, and I know they both divide by 2 because they're both even numbers. Okay, so 42 and 36 both divide by 2, so let's start easy. Divide 42 by 2, I get 21. Half of 36, or divide it by 2, is 18. Okay, so now you look at the 21 and the 18, and what goes into both of those. If you know your times tables, you know that 3 does. Okay, so 3 goes into 21 7 times. 3 goes into 18 6 times. Okay, if you don't know your times tables, it's going to take a little bit longer, but you can still do it. Okay, 2 plus 1, whoops, can't read that because it's too thick. Let's try it this way. 2 plus 1 is 3, and 3 divides by 3, so 21 divides by 3. 1 plus 8 is 9, and 9 divides by 3, so does 18, right? Okay, so 21 divided by 3 is 7. 18 divided by 3 is 6. So when we rewrite that, we get 7/6 with the negative in front of it, which is exactly what they got, right? Okay, I don't care which process you use, whichever one makes more sense to you. I use the process 3 like I've shown you, but sometimes I use process 1 because I know exactly what I'm dividing by, so I write it to the side. Okay, so process 2 I generally don't do very often at all because to me that takes up too much time and effort. Okay, let's look at, sorry I'm moving them all around there for you. Okay, so 24 and 30. Okay, I know that 24 and 30 both divide by 6, right? So I'm going to divide them both by 6 and see where I am. Okay, so divide by 6, divide by 6. It may be done in one step. It might not be. So see, you can combine different of the different processes at the same time if you want. Doesn't matter. Okay, so I didn't even check to see if this was a JCF or not. I just divided. So 24 divided by 6 is 4, and I'm going to bring the negative up with the 4 so I don't forget it. And 30 divided by 6 is 5. And now 4 and 5 don't divide by anything specific, so I'm done. Okay. Could I do this process with a different number? Absolutely. What if I just recognized it was divisible by 2? Okay. So negative 24 divided by 2 is 12. 30 divided by 2 is 15. But now I have to go again, don't I? Because 12 and 15 both divide by 3. Okay, so see, this is kind of process 1 done multiple times because we're not using the GCF, we're just using a common factor. Okay, so 12 divided by 3 is 4, and it's going to be negative. 15 divided by 3 is 5, so negative 4/5. Same thing. Okay, so negative 24/30, and 24 divides by 3, you get 8. 30 divided by 3 is 10. 8 and 10 both divide by 2, so we still get negative 4/5. Okay, so pick the way that works the best for you and do it. Okay, all right, 54/90, I know they both divide by 9. Okay, because 9 times tables, that's on both of them, right? Okay, so I'm going to start with that. And we get 6 and 10. Now 6 and 10 both divide by 2. Okay, I like doing it this way because it doesn't take up as much vertical space as that does. You just have to rewrite things going sideways, but that's okay. All right. And there wasn't a negative on that one. Whoops. So it's positive 3/5. Okay, next. Okay, these numbers are getting pretty big. I would not want to do a tree for both of those to figure out what their prime factorization is. Okay, so I'm going to concentrate more on the two ways that I did it last time. Okay, so like this or like this. All right. Okay, so here we go. I'm going to zoom in on this one. And I'm sorry if it makes you motion sick. All right, so I'm looking at the 204 and the 342 and seeing what they divide by. Okay, you could look down here and see what they've divided them in, what they get when they divide them, but I'm not going to worry about looking at that. Okay, I know that they end in a 4 and a 2, so they're divisible by 2. Okay, so if we divide both of them by 2, we get 102 on the top and 171 on the bottom. Okay, how did I know that? Half of 20 is 10 and half of 4 is 2. Half of 34 is 17, half of 2 is 1. If you can't take exactly half of the numbers, then that doesn't work. But okay, so now I'm looking at 102 and 171, and they're not both even this time. They don't end in 5s or 0s, so I can't use that. So what I'm going to do next is add them up and see if they're divided by 3. So 1 plus 0 is 1, plus 2 is 3. 1 plus 7 is 8, plus 1 is 9. Sure enough, those two green numbers, 3 and 9, divide by 3. Okay, which means, okay, all that you can do in your head. I'm going to divide top and bottom by 3 now. Okay, and if you cannot do this part in your head, do that off to the side. Okay, so 102 divided by 3 gives you 34. And 171 divided by 3 gives you 57. Okay, now at this point, you're kind of out of divisibility rules that we haven't already used, right? Okay, doing a tree might be good at this point. I just don't like using these big numbers. 34 is 2 times 17. That's as far as it goes. And 57, if you add them up, you get 12. So 12 is divisible by 3. You know, 3 goes into here. This is 3 times 19. And they don't have anything in common, so you're done. That's your answer. Okay? And yeah, you'll probably get something hard like that on an exam, so you need to know how to do it with the weird, wonky numbers. Okay? Let's take a look at this one now. All right, if you know your times tables, all the way through 12s, these are both divisible by 12. If you don't, let's assume you don't, let's start basic. Okay? Let's divide them both by 2. Okay, now we could go this way and this way, like we're doing process 4. 4? Haha, I just made one up. 3. And so let's give us some more space on this one. Okay, so divide them in half, and you get 48 and 54. Okay, now 48 and 54, if you know your times tables again, is 6s, right? 6 goes into that 48, and it also goes into 54. But, again, we're going to assume you don't. Let's just do 2. So 2 goes into 48 24 times, and half of 54 is 27. Okay, now at this point, if you add these up, 2 plus 4 is 6, and 2 plus 7 is 9. 9 and 6 are both divisible by 3, so we can divide 24 and 27 by 3. 24 divided by 3 is 8, 27 divided by 3 is 9, and we're finally done, right? So negative 8/9. Okay, I'm going to zoom back out so you can see those two in the same screen. Okay, so you're going to use a lot of space when you have big numbers. It's either going to be sideways like this one, or it's going to be vertical like this one. Or you're going to need to know bigger numbers that divide into the originals. Okay, so for example, like I said, if you know your 12s, okay, so let's divide by 12 here and here, and you get 8/9. You're done in one step. Okay, so your times tables are definitely a benefit, but you can do it without. Okay, now I'm going to save the exponent one until last. Let's do this one. Okay, since I don't have room to go vertically, I'm going to go sideways on this one. Okay, so let's divide them by 2, because we know they're even, right? Okay, so 252 divide by 2. So the benefit of using bigger numbers is you don't have to do long division as often. Okay, so 126. Now 330 divided by 2. Now this unit, you cannot use a calculator either, so you need to learn your times tables. Okay. So 165. They're still big numbers. We cannot divide by 2 again because we endeth an even here but a 5 here. This one's divisible by 5, but that one's not. Okay, so let's add them up and see if we can divide by 3. 1 plus 2 is 3, plus 6 is 9. So that one we are able to divide by 3, that is. So 1 plus 6 is 7, plus 5 is 12. Sure enough, that one divides by 3. Okay, so let's divide them both by 3 this time. So divide by 3, divide by 3. Okay, so off to the side again. 126 divided by 3 goes in 4 times. Bring the 6 down 2 times. So 42 on the top. 165 on the bottom, divided by 3, goes in 5 times, and 5 times. So 55. Whoa, that's a weird 5. Let's try it again. All right, so how do you know if you're done? You check all your divisibility rules. Okay, I'm going to double check and see if I can break either one of these down farther and what I'm going to break them into. So I'm basically doing a factor tree. Okay, so this is 5 times 11. Now I'm going to break this one going up. This is 6 times 7, and 6 is 2 times 3. So 2 and 3 and 7 on the top, 5 and 11 on the bottom. Nothing in common, so I'm done. Wow. Kind of combining all kinds of things on that one. All right. This one. I don't know why they're throwing it in on this particular page, but here we go. What this actually means is, let me write it completely out, is that. Holy cow, right? Okay, so we have 7 2s, 4 3s, and 3 5s on the top. On the bottom, we have 5 2s, 3 3s, 3 5s, and a 7. Okay, so this is the advantage of writing it using exponents, right? All right, so this is their process 2, I believe is what it was. Okay, so now we're going to cancel or divide everything that we have in common. So there's our 2s. Okay, so 3s are a different angle here. 1, 2, 3 of them. Now 5s, I'm not going to draw them on an angle. I'm just going to do them individually here. So we have 1 5, 2 5s, and 3 5s. So what do we have left? We have 2 2s and a 3 on the top and 1 7 on the bottom. So this becomes 2 times 2 times 2 times 3 over 7. So 2 times 2 is 4. 2 times 3 is 12. No, it isn't. It's 6. 4 times 6 is 24 over 7. Okay? That's the extremely long way. But it makes sense, doesn't it? Okay, the short way is, let's look at the 2s. Okay, on the top we have 7, and the bottom we have 5, just like it had here. So the 5 on the bottom are going to cancel 5 of these. These 5 2s cancel 5 of these and leave you with 2. Okay, the 3 3s on the bottom cancel with 3 of those and leave you with 1. The 3 5s cancel with the 3 5s completely, and then the 7 is left. Okay, so we have 2 squared and 1 3 over 7, which is, okay, 24. I lied, isn't it? I made a mistake. I'll fix it. 12 over 7. And you probably figured out where the mistake was. Right here, I circled that 2 that I shouldn't have circled, right? It was crossed out. So let me fix that one. Okay, so we really only have 2 2s and a 3. So 2 times 2 is 4 times 3 is 12 sevenths. Okay. And we're going to get into this type of a situation later when we add in variables. Yeah, variables and fractions and exponents. Okay, so don't worry about it too much right now, but we'll get to it later and I'll explain it all over again. Okay, this one is setting up a story problem as a fraction. Okay, so let's take a look at it. In a company of 225 employees, 50 of them ride their bike to work. Write a fraction to represent how many people ride their bike to work in lowest terms. Okay, if you remember the very beginning, I think it was 2/3, all the way at the beginning of this module, I wrote this means 2 out of 3, right? Because we had our circle broken into 3 sections and we wanted to count 2 of them. So 2 out of the 3. Okay, so this out of is a division or a fraction bar. Okay, so we're going to use that in this problem because 50 out of 225 employees ride their bike to work. So that becomes 50 out of 225. And now it says write it in lowest terms. So let's divide top and bottom by 5. How's that? Okay, so in this case we get 10, and then 225 divided by 5 is 45. And then we can divide by 5 again. So 10 divided by 5 is 2. 45 divided by 5 is 9. So your answer is 2/9. So 2/9 of the employees of that particular company ride their bike to work.